Hello, Algebra 1 students. Today is our second day of notes for solving systems of linear inequalities. So just like last time, I'm going to go through the steps with you and all the slides I would have gone through with you in class and do the examples. And then you will have the notes here from this video. So we have been graphing linear inequalities one at a time. So today we're going to talk about systems of linear inequalities, which remember when we talked about systems of equations, that meant two or more. So today we're going to talk about two or more linear inequalities. Specifically, we're going to talk about two linear inequalities. So here are the steps that we are going to follow in order to solve systems of linear inequalities. So I'm going to pause for a second so you can pause the video and write these 3 steps down. So our 3 steps to graphing systems of linear inequalities are to graph the first inequality, and then we're going to shade lightly. And then we're going to graph the second inequality and make sure to shade lightly. And where our shaded areas overlap, we are going to shade in darker because that is going to be the answer, because that's where the points are going to be where they make both inequalities true. So just like when we were solving systems of linear equations, we had one point which was true and on both lines. We called that the point of intersection. Here we're going to have an area of intersection. So we're going to find the shaded area where all the points in that area make both inequalities true. All right, so here's our first example. Our first example is y is greater than negative x minus 2, and y is less than or equal to 3x plus 6. So I'm going to use blue for the first line. So this line I'm going to make blue. So y is solved for. So what we're going to do is we are going to start at our b, which is negative 2, 0, negative 2, and we're going to write a dot. And then since our slope is negative 1, we're going to go down 1 over 1. And then remember, we're going to make that a dotted line because it's a less than, or I'm sorry, it's a greater than symbol. And so all the points on our line are not part of our solution. So we're going to make a dotted line. And then we're going to test a point. And if we test the point 0, 0, which is right there, we are going to plug in 0 for y and 0 for x. And so we're going to get 0 minus 2. And is 0 greater than negative 2? Yes, it is. So we're going to shade lightly in this direction. All right. To do the second one, I'm going to change it to red, and I'm going to do the second one here in red. So our b for y is less than or equal to 3x plus 6 is 6. So I'm going to go to the point 0, 6. And I'm going to make a dot. So that's 1, 2, 3, 4. And my slope is 3 over 1. So I'm going to go up 3. Oops, hang on. That's only 5. All right. There's my 6. And I'm going to go up 3 over 1. And I'm going to make that line solid because it's an or equals 2. And then I'm going to test a point 0, 0. So I'm going to get 0 is less than or equal to 3 times 0 plus 6. Or 0 is less than or equal to 6. Is that true? Yes, it is. So again, I'm going to shade towards the 0. And then the place where they overlap, I'm going to try to make that purple. All right, the place where they overlap is in this section right here. So I'm going to make that the purple part. Where they overlap is my solution. So in this area, if you picked any one point out of this area, you would get a true statement for this inequality and a true statement for that inequality. All right, so we are going to do a second example. Our second example is y is less than x minus 4, and y is greater than or equal to negative x plus 3. So for our first line, again, I'm going to make that one blue. We're going to start at 0, negative 4, and we're going to go up 1 over 1 because our slope is 1 over 1, and that is a less than symbol, so I'm going to make that a dotted line. All right, and then when I test my point, 0, 0, I'm going to get 0 is less than 0 minus 4, and is 0 less than negative 4? No, it's not, so I'm going to shade away from 0, 0. All right. For my second line, I'm going to make that one in red. So we have y is greater than or equal to negative x plus 3, so we're going to start at 0, 3, because my b is 3. And then I'm going to go down 1 over 1. And I'm going to make that line solid because I have this or equal to, so all the points on my line are part of my solution. And then if I test the point 0, 0, I get 0 is greater than or equal to the up is 0 plus 3, or I get 0 is greater than or equal to 3. Is 0 greater than or equal to 3? No, it's not, so I'm going to shade away from 0. So where do these two inequalities overlap? Well, they overlap in this little triangle portion right here. Now, again, your shading will be much better because you have pencils. I'm trying to use a stylus on a computer. So that is our second example, and I have one more example for you where we have to solve for y for one of our equations, and then we will be done. All right, here's our last example. So I'm still going to do the first one in blue, but I have to solve for y first. So I'm going to subtract my x over, and so I would get the opposite of y is less than negative x plus 2. And then I'm going to divide by negative 1. And I'll get y. And remember, if you divide both sides of an inequality by a negative number, you have to flip the symbol. And then I negative 1 divided by negative 1 is a 1x. And a 2 divided by negative 1 is a negative 2. So I have y is greater than 1x minus 2. So I'm going to start at 0, negative 2. My slope is 1 over 1, so I'm going to go up 1 over 1. And I'm going to make that a dotted line because I have a greater than symbol. If I test the point 0, 0, I'm going to have 0 minus 0 is less than 2. So is 0 less than 2? Yes, it is. So I'm going to shade towards 0, 0, which is up this way. My second line is a vertical line. That vertical line is it as x equals 3, and it's going to be solid because it is or equal to. So I have that line. And if I test the point 0, 0, I will get 0 is greater than or equal to 3, which it is not. So I'm going to shade away from 0. So where do those two intersect? Well, it's up in this corner over here. So I would again, shade in this dark part where they overlap. So the purple is my solution. So hopefully that helps you to graph linear inequalities. I hope you are all safe. I hope you're all healthy. And I hope you all have a great